The sun emitted a strong solar flare peaking at 12:02 p.m. EST on December 14, 2023. NASA's Solar Dynamics Observatory, which watches the sun constantly, captured an image of the event. Solar flares are powerful bursts of energy. Flares and solar eruptions can impact radio communications, electric power grids, navigation signals, and pose risks to spacecraft and astronauts. This flare is classified as an X28 flare. X-Glass denotes the most intense flares, while the number provides more information about its strength. To see how such space weather may affect Earth, please visit NOAA's Space Weather Prediction Center, the U.S. government's official source for space weather forecasts, watches, warnings, and alerts. NASA works as a research arm of the nation's space weather effort. NASA observes the sun and our space environment constantly with a fleet of spacecraft that study everything from the sun's activity to the solar atmosphere and to the particles and magnetic fields in the space surrounding Earth. Before that, the sun emitted a strong solar flare peaking at 4:46 p.m. EDT on August 7, 2023. NASA's Solar Dynamics Observatory, which watches the sun constantly, captured an image of the event, according to space weather specialist Dr. Theskov. During this event, auroras will illuminate the sky due to the intense interaction of CMEs with the thermosphere layer of the atmosphere, where ions are free to move. Solar storms typically disrupt radio and GPS signals as a potent eruption of plasma and magnetic fields from the sun's corona. A CME can interact with Earth's magnetic field and ionosphere, leading to geomagnetic storms and auroras. How solar activity can affect Earth. Large solar flares can lead to a radio blackout storm on Earth. The solar storm can endanger astronauts and Earth-orbiting spacecraft. The solar storm can hit Earth's magnetosphere and induce currents in electrical systems on Earth. During this time, power grids are vulnerable and can cause major blackouts. What is a solar cycle? It is driven by the sun's magnetic field. And every 11 years or so, the sun's magnetic field flips, and the north becomes south and vice versa. Changes in the sun's magnetic field affect the amount of activity on the solar surface. The flip in the magnetic field has ripple effects on the solar system. Planets without a protective magnetosphere, such as Venus, feel the full impact. Earth's magnetic poles also flip, but the interval between the reversals is much longer, averaging about every 300,000 years, according to NASA Climate. The last pole reversal happened about 780,000 years ago, according to Space.com. When the solar cycle is at peak activity, it can pose a risk to communications on Earth and satellites. One spectacular side effect of increased solar activity during the solar cycle is aurora. When the energetic particles from the sun slam into Earth's atmosphere, dazzling light shows illuminate the sky. The color of the aurora depends on which chemicals in Earth's atmosphere the particles hit. Red hues are produced from collisions with nitrogen molecules, and green is produced by oxygen molecules. NASA, the U.S. Space Agency, has warned of a solar storm that will disrupt the internet and electricity on Earth. According to various media reports, NASA got the information regarding the solar storm via its mission, Parker Solar Probe. It is a mission that launched in 2018 to unlock the mysteries of the sun's corona and solar wind. In 2021, NASA sent a spacecraft the size equivalent to a small car to travel directly through the sun's atmosphere to trace the flow of energy and determine the wind speed. According to NASA's probe, solar activity is likely to ramp up until the predicted solar maximum in 2025. According to Space.com, the heightened solar activity poses a risk to satellites, spacecraft, and even spacewalking astronauts due to increased radiation exposure. The solar activity will also pose a risk to Earth, as it will trigger large geomagnetic storms that can interfere with high-frequency radio communications and global positioning systems GPS. This might cause an internet outage, meaning an internet shutdown. However, the mystery regarding the date and time of such activity remains. What causes solar flares? The sun's surface is a magnetically mixed-up place. Magnetic fields are created from electrically charged gases, generating electrical currents that act as a magnetic dynamo inside the sun. According to a statement from NASA, these magnetic fields twist, tangle, and reorganize themselves due to the turbulent nature of the gases that create them. According to NASA's Space Place, this unsettled magnetic field behavior, also known as solar activity, can trigger solar flare eruptions from the surface that release vast amounts of electromagnetic radiation, a form of energy that includes radio waves, microwaves, X-rays, gamma rays, and visible light. Solar flares tend to originate from regions of the solar surface that contain sunspots, darker, cooler portions of the solar surface where magnetic fields are particularly strong. As such, the number of sunspots can indicate the likelihood of a solar flare eruption. Solar activity follows an approximately 11-year cycle, with the peak of sunspot activity coinciding with solar maximum, and a sunspot hiatus coinciding with the solar minimum. According to the Space Weather Prediction Center of the National Oceanic and Atmospheric Administration (NOAA), during periods of low solar activity, when no sunspots are present, it is unlikely that a solar flare will occur. Solar activity is on the rise as we experience solar cycle 25. Solar maximum is predicted to occur in 2025. To find out if there is a solar flare today and to keep up with the latest space weather findings, SpaceWeatherLive.com records the most recent 24 hours of solar X-ray data from the primary GOES-16 satellite and displays such activity in useful graphs along with the percentage chance of different types of solar flares. In 1989, a large solar flare accompanied by a coronal mass ejection hit Earth, plunging the entire province of Quebec, Canada, into an electrical blackout that lasted 12 hours. According to a NASA statement, the solar eruption triggered a geomagnetic storm on Earth, resulting in aurora borealis, or northern lights, that could be seen as far south as Florida and Cuba. So, friends, what do you think about this phenomenon? Write your views in the comments section, and don't forget to subscribe to our channel to get interesting videos. If you like the video, please like and share the video.